Indonesia. According to data from Pus Hydrosal on 2018, Indonesia has a total coastline length of 108,000 kilometers. Therefore, Indonesia has great potential as a salt-producing country. However, this potential has not been developed properly so that it cannot meet the needs of the community. One of the causes of low salt production in Indonesia is in the process of making salt. Salt crystallization process is influenced by the rate of formation of the salt crystals, while the rate of crystal formation is influenced by the number of impurities. The impurities in the salt consist of sludge, hygroscopic impurities such as calcium and magnesium ion, and other reducing agents. But based on the research of Variana and Hakim on 2015, the problem can be solved by addition of polyaluminum chloride or PAC as a synthetic coagulant. However, the addition of PAC will produce a new impurity like epichlorine. It is a factor that causes cancer and Alzheimer's disease if consumed continuously, so that we create an innovative concept of the potential of biopolymers as coagulants to increase the recrystallization rate and salt purity.
The results of the literature study are classified in the synthesis matrix, which will then be studied and analyzed. The method of discussion in this paper is descriptive qualitative, which discusses the potential of biopolymer coagulants to increase the recrystallization rate and purity of the resulting salt. Secondary data obtained from literature search were analyzed and written directly without any reprocessing of data. The data is compared and then a conclusion will be drawn, which will be written descriptively in this paper.
Traditional salt in Indonesia using natural method, which is evaporation. The manufacturing process is carried out in several stages, namely drying seawater, evaporation, deposition, and crystallization. The traditional process of making salt is claimed to take a long time, which is about 1 month. According to the Van Ente 2009, the crystallization rate is determined by 2 factors, namely the rate of nucleation and the rate of growth of the nucleus toward the final crystal aggregate. The existence of external influence on the formation of crystal nuclei had led many researchers to begin developing new research on crystallization method to accelerate the rate of crystal formation. The method of crystal formation largely determines the rate at which it is formed. This is why it is necessary to find the right method so that the crystallization process of ionic molecules can occur quickly. Based on the literature, it can be concluded that the evaporation method using microfluidic and numerical simulation are used to simulate crystal growth. However, this method requires high cost, so it is impossible to implement it on a large scale. Therefore, further research is needed to find the right method with affordable production costs to increase salt production in Indonesia. One of them is the crystallization method. The production of salt in Indonesia still relies on the heat of the sun, so that during the rainy season, salt farmers in Indonesia will find it difficult to produce good quality salt. Based on this, many studies have been carried out to find the right method to produce quality salt in accordance with the standard of salt demand in Indonesia. Based on this literature, it can be argued that the most effective method for purifying salt from seawater or brine is the conventional evaporation method with the addition of PAC coagulant. The use of coagulant for salt purification is supported by research Ratnayana et al. 2014. In this research, the salt-making process was carried out using a chemical physics method consisting of stage, coagulation, precipitation, and filtration. Therefore, currently, the addition of coagulants for salt purification has been developed. Based on this literature, the most effective coagulant is chitosan. Chitosan can be found in arthropods and several types of fungi. Chitosan has several advantages including environmentally friendly, biodegradable, and can absorb various metal ions. Chitosan contains reaction hydroxyl groups and very high reactive amino groups. This group make chitosan has a strong absorption capacity. The mechanism of chitosan as a coagulant depends on the amino group. The protonation of this group make chitosan positively charged and binds the impurity compounds in negatively charged of seawater. Impurity compounds such as calcium sulfate, magnesium sulfate, calcium chloride, and magnesium chloride will experience destabilization where the negative ions such as sulfate and chloride will bind to the amino groups of chitosan so that they precipitate faster. To remove positive ions such as calcium and magnesium, further treatment will be added by adding natrium carbonate and natrium hydroxide to separate from the solution so that salt crystal form faster. Based on this explanation, it can be concluded that the chitosan, which is non-plant-based coagulant, is the right type of natural biopolymer to be used in this study.
The conclusion from this research is based on the literature study. It can be concluded that there are various salt crystallization methods to accelerate the crystallization rate of salt. The potential of biopolymer can accelerate the rate of salt crystallization because it can speed up the coagulation process to precipitate impurities on the salt.